All right, I'm going to introduce Matt Lockyer. He is our meta mascot for ETH Denver. Just kidding. He actually does help us with ETH Denver. He's from Vancouver. He is an active developer, writer, and strategist in the blockchain ecosystem. He works with lots of different projects as an active consultant and advisor. He authored the Ethereum ERC 998 standard for composable tokens, and his article on TCRs was published. That's token curated registries in A16Z's crypto canon reading list. He's the founder of the Nifty Magicians, and that's a group of over 300 blockchain developers, and he currently educates enterprise innovation labs and startups on technical architectures and also crypto engineering processes. So with that, my pleasure is to introduce Matt Lockyer.
Thanks, John. I think the mics are working out okay. Awesome. Hey, everybody. I think I've already got the intro, so that's great. And just to explain, just don't want to get feedback there. Just to explain the T-shirt, some guys from Denver, just like they kind of like mugged me in an alley, and they put this T-shirt on me. It's the official Ethereum Denver T-shirt. It's really awesome. There's a bufficorn here, and John, this is a spork sporting marmot. Spork marmot. Okay, just so we get our mythology straight here. All right, so I'm here to kind of talk to you guys about basically Ethereum development, but just to sort of kind of introduce the session. You may have seen a lot of really polished talks where people were sort of giving you historical context of, Bitcoin or cryptography, and you were just listening the whole time, and these were really smooth presentations. This is not going to be that at all. So we're just gonna, do a little intro, little bit of a polished talk, but then we're gonna go off-roading. We're gonna have you guys kind of trying out a few things. I'll buzz around the room. We'll make sure everybody's on the same page. And what we're really trying to accomplish here is we're trying to basically introduce Ethereum, how it's different from other blockchains. We're going to specifically dive deep into the development tools. So how do developers develop smart contracts? We're only looking at a small subset of the tools and the languages to develop Ethereum smart contracts, but arguably some of the most used and the most popular. And then we're going to look at what writing contracts, tests, and deployment actually looks like. So John already gave a little bit of my background, so I'll skip over. I'm assuming that later on I may run out of time. So part one, this is broken into two parts where we'll sort of do an intro, and then we'll get you guys kind of maybe installing some stuff if you don't already have it installed. And then just trying out a few things. And then part two, we're going to dive a little bit deeper. So the part one overview is basically just how Ethereum works, smart contracts, what are they, how do they work, and just setting up the development environment. So the nuts and bolts of the Ethereum blockchain, let's dive in here. So we all, I guess, are attending this conference because we're aware of these things called blockchains. So we've obviously heard of Bitcoin. So Bitcoin by design has a very limited sort of kind of script surface to it. And I say that's by design because they want it to be very, very minimal, very secure, and very simple. And Bitcoin really does kind of one thing and one thing really, really well. You kind of, can send Bitcoins from accounts to other accounts. Now there are some features in there like multi-sig and other interesting things. But for the most part, Bitcoin tries to kind of serve that one purpose. There's other distributed ledger technologies or DLTs that we may have heard of, like a hyperledger or something like that. And those are kind of like, private ledgers, private databases. And then we've got sort of the other ones that are like the Ethereum family of sort of more smart contract sort of blockchain networks, Polkadot, this new Libra one. I've tried to update my slides. Love it or hate it, it's still a smart contract blockchain. So rootstock, which is sort of like, sorry, I seem to be pulling on this. Rootstock, which is kind of like a merged mine, getting smart contracts to run with smart Bitcoin, but it runs the Ethereum Virtual Machine as well. So what is Ethereum then? Like, how is it kind of different from Bitcoin? Well, you could really think of it as sort of like if Bitcoin is a public, immutable, censorship-resistant digital ledger, then Ethereum could be viewed as sort of this public, immutable, decentralized application state where you can store, all manner of things on this decentralized database. So anyone can join, anyone can publish smart contracts, anyone can transact, and anyone can read the state. So updates are basically these transactions. So this is not unlike other databases. There's databases out there like that are sort of immutable and transactional. So like some things like Apache Kafka. I'm not sure if kind of Spark falls into this category, but there are lots of databases out there that are basically just building on top of previous history. So that's what we mean by transactional. You're sort of making updates, and every update is the delta to the data that was there before. And this is verified, like the total, kind of like the future, the current state, like the absolute sort of truth in the future is sort of verified by these Merkle proofs. So that's how it's sort of done very, very fast. And the last point here, it's a quasi-Turing complete global computer. So what I mean by quasi-Turing complete is that you can kind of do Turing complete logic, but however, it will not, there's no way to kind of send the Ethereum virtual machine into infinite loops and stuff, because there's a concept which we'll touch on in later slides called gas, which sort of gives an overall limit to how much computation can be done. So some technical details, just in case you guys don't know it. Maybe I'll stop right now and mix it up, just kind of ask you guys by a show of hands, like who knew all of this before? Don't be shy. It's like half the room, and the other half just didn't want to put their hands up, or no, I'm just kidding. Okay, well, this just sort of helps me gauge. I'll just sort of like, impromptu on the fly, kind of tailor the speed here. And if I'm going too fast, if you want to ask a question, just like, you guys won't interrupt my flow or anything, just shoot your hand up. So ETH is the settlement currency of Ethereum. It's very interesting you should just know this right off the bat. It is not an ERC20 token. It is not a token. It is not like the other tokens. If it was, we'd have a real problem because of other things that you may have heard of earlier in the day, like the DAO hack or other things like smart contract exploits, reentrancy things. So Ether is sort of like it's a special, it's like the only main currency. So Ether is to Ethereum like little b Bitcoin is to the big B Bitcoin network. So there's 10 to the 18 Wei, which is the smallest unit. So that's your sats or your satoshis in Bitcoin. However, it's not 10 to the 9, it's 10 to the 18. I think it's 10 to the 9 in Bitcoin. Yeah, I think so. So it's 10 to the 18 Wei, which is the smallest denomination of this Ether currency, makes up one ETH or one Ether. And that price, I don't care. I'm not a price person, so I don't know what it is today. But you can click that link if you have the slides, and it'll tell you. So computation uses gas in Ethereum, and we'll see what computation looks like later. We'll see what these function calls are, what you can do with the language. And by charging for computation, as I mentioned before, this is a solution to the halting problem. So basically the halting problem is you can't have a global computer where all these miners have to compute some smart contract logic if there is a way for somebody to deploy a smart contract that ends up in an infinite loop, right? Because you're gonna basically freeze up all those computers, and all those computers are gonna be like stuck in some while loop or some for loop. So basically, there is an upper bound to how much you can do. So every single statement in Ethereum that executes costs gas. And basically, there's an upper limit to how much gas can be used inside a block. And there's basically a gas limits that users can send or that can specify their gas limit, like how much gas they're willing to use for their transaction, which helps a user kind of not get ripped off by some smart contract code that's going to gobble up all their Ethereum in the form of gas and basically just kind of spray that out to the miners. So this is interesting. So it's kind of a bit of an innovation there. So the EVM, which I mentioned before, is the Ethereum Virtual Machine. It's a 256-bit virtual machine, and it's because in large part, we're dealing with hashes, we're dealing with very large numbers that we want to have a lot of accuracy. So for example, 1 ether has 18 decimal places, and that way we can make sure we can slice and dice 1 ether into a lot of itty bitty little chunks and make sure that we have some accuracy there. Storage. So every smart contract has its own key value database. I kind of say that a little bit like this. It's basically every contract does have some sort of storage. You, the developer, choose how that storage is used, how it's mapped, but you basically have this database. You can store as much as you want on the Ethereum blockchain if you're willing to pay for it. Storage is one of the most expensive things. And that's also because it leads directly to the size of the Ethereum blockchain, which you guys may have heard raging debates about. Ethereum blockchain, full archival nodes, they're terabytes, blah, 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 blah. I don't want to get into any of those, but we'll get to the dev tool stuff. So languages, Solidity, it's sort of like a JavaScript-y kind of language. So that's the most popular language that's being used right now to create these Ethereum smart contracts. There's a new version of a Python-style language called Viper. It is, there was a previous language called Serpent. I think you guys can get the naming thing right. And then there's this, there's a very, there's a bunch of languages that will compile to EVM bytecode, but they're not really in wide distribution. So I mentioned this LLL Lua. It's like Lua script. Okay, and then networks. So something to keep in mind, there are test networks. There's the main Ethereum network, obviously, where the ether is real and you're playing for keeps. But there's all sorts of test networks, and what you'll see today is we'll just be spinning up these private networks. They're not full-fledged Ethereum networks, but they are sort of simulated test nets. So we can just boot up a test net locally on our machine. We can try out a few things. So I mentioned gas costs before. There's this paper called the Yellow Paper. It gets updated on a fairly frequent basis. And basically, there's an appendix in there, which is Appendix G as of the screenshotting of this page in this Yellow Paper. But it basically itemizes all the gas costs. I realize it's very small for you guys right there, but it's stuff like G call, G store, G memory, things like that, GTX create. So it's basically itemizing all of the statements that you could have in essentially Ethereum bytecode, which a language like Solidity would compile down into. But it's basically going to tell you how much each of these things cost in terms of these gas units. So let's talk a bit about the accounts and transactions of Ethereum, just to kind of wrap our heads around this. There are two different types of accounts in Ethereum. There's an externally owned account, so it's often referred to as like an EOA. You may have seen the abbreviation. This is kind of like your wallet, like in Bitcoin. It's basically just like the main account that an end user would have. It's controlled by this private key. It contains a nonce, a balance, a storage root for all of its transactions. And a typical transaction cost for sending Ethereum between two accounts is 21,000 gas. So that's sort of like a bit of a baseline. And then there's contract accounts. So what is a contract account? A contract account is basically an EOA. It's like an externally owned account plus this block of code. So where is this code? Like, where is Ethereum bytecode stored? It's actually stored on the Ethereum blockchain. So when you deploy a contract, you're actually kind of using storage as well to deploy your bytecode. So basically, your contract address will also have like a code field, and it will reference like internally some location on the Ethereum blockchain where your bytecode will be. And that's so that everyone who's sort of running the Ethereum blockchain is running the same bytecode. We can all see the same bytecode. We know where it is. We know we're not getting into any sort of contracts that are run in like a closed system. We don't want that, right? Because we don't want people to kind of arbitrarily run code that our accounts have basically said, hey, I'm just passing some ether through here, because that code could do a bunch of stuff. So all the code is out there. It's on the Ethereum blockchain out in the open, and everything is sort of mapped up. Sending ether to contracts could be more costly than like an externally owned account to an externally owned account. So for example, if I were to send John some ether just from wallet to wallet on MetaMask, for example, it's only going to cost 21,000 gas units. But if I were to send John ether through, let's say I'm going to forget the name of this. What's it called when you send someone's funds, but it's like held for a bit and then custodial? Escrow. There we go. Thank you, escrow people. So if I were to send John some funds through like an escrow contract that was checking a condition that something else was met, maybe this condition is on the blockchain, maybe there's an oracle that's going to say, yep, that's good, and at a later date it's going to go through, that's going to cost more gas because we're doing stuff, we're doing computation. So transactions. A transaction can contain a receipt, a signature, a value, a gas limit, a gas price, and optionally some data, so some arguments. Let's kind of conceptually go through a life cycle. So at a local node, or just on someone's computer, and then passed to a relayer like a node. A lot of transactions on Ethereum go through light clients, so they'll go through a MetaMask, which is using Infura in order to broadcast that transaction. But in a general sense, the transaction is created, it's signed by the user's private key, it's somehow sent to a node, so that could be through a MetaMask, through the Infura network, then out to a node. Then it gets hashed and broadcast to the entire network. That's when it would sort of end up, I believe, if you guys are like Bitcoin experts, don't yell at me, but I believe that's when it hits sort of like a mempool, like the transaction's hashed, it's like waiting to be included in a new block. And then all the nodes would decide based on the gas price that the user's paying, so like your fees in Bitcoin, that it should be included in the block. And then there's new state and new events. So if it modified the state of some smart contract, then you would see that update. All the miners would basically propagate that state. So it's kind of like databases replicating the state until they've kind of all come to come to a consensus. And then mining occurs. So the mining right now in Ethereum is just proof of work, the same as Bitcoin. It's moving to proof of stake. We're not talking about that today. So then there's a winner of the currently mined block, and then that's broadcast out to the network. This is verified by everybody, and then the updated state and events are sort of released out and kind of confirmed for everyone. And then, of course, there's that concept of confirmations. So new blocks are placed on top, and similar sort of properties to Bitcoin, like basically however many more blocks are placed on top, that's sort of your security. And then there's some economic like upper bound depending on the price of Ethereum at the time and how many blocks after. So that's how expensive it would be for basically the whole chain to kind of switch to a longer chain. So transaction IDs are a 256-bit hash of the transaction for tracking. There's an example on Etherscan. I'll save you guys the clicking, but basically you can take a look at any transaction on Etherscan. So what are messages? So smart contracts can talk to other smart contracts. So just because I want to send Ether to John through an escrow contract, that escrow smart contract could check another contract, which could check another contract. And these don't have to be, John was talking about Opolis and how it's sort of pulling together a lot of this infrastructure and putting it under one roof. This is sort of how it's done. Like all the contracts are out there on the Ethereum blockchain and all of their functions are there. And so if I want to send Ether to John based on some CryptoKitty transaction that's going to happen, maybe happen in the future, maybe it's already happened, maybe we're just checking the value, I could do that. I could say, hey, John, I'm going to escrow 1 Ether for you, but I'm only going to let that go through this escrow contract as long as this CryptoKitty gets transferred back to me. So you can do all sorts of interesting stuff like this. You can build dApps on top of other people's protocols. In fact, this is how a lot of the space is created. So what goes in the data? Let's get really deep. Trust me, guys, this is the end of this part. But it's basically all the prelim that you need to know. So dissecting a function call, it's kind of interesting. I like it. So if you break up this really long function call, you basically get the name of the function. So the name of the function is transfer, and then you have this this address field. So it's the type of the first argument. I'll just wiggle my mouse here. I'm looking down at the bottom here. So the hash of this first bit here is the hash of literally the letters transfer bracket address comma uint 256. So that's the 2 arguments that this function is going to take. And then you would have the address 2, which is the first argument, and it's padded by I don't know how many zeros that is. Apologies, but it's padded up until this point here. And then there's the uint 256. This is going to be the value, and this is also likewise padded, and basically that makes up your function call. So basically you have kind of a hash of the signature and then the arguments, and of course they're padded. I think it's 256 bit padded. This is in hex, so however many zeros that is. So that's what a function call looks like. And then one thing that should be mentioned is that contract addresses, because we're kind of talking all about smart contracts today, are basically, is that time left? Okay, that's a little weird. I'm only 25 minutes in, guys. Don't yank me off. So dissecting contract addresses, they're basically deterministic. So you kind of need to know this, and the reason why this is important is if you know the address of the contract contract creator. Just like I said, every externally owned account has a nonce. And contracts, by the way, smart contracts have a nonce, and they can create other smart contracts as well. So you can have a smart contract that's like a smart contract factory, but there's an address of either an externally owned account or a smart contract plus a nonce that is hashed, and then that spits out the next contract address from that account. So that's really interesting because let's say your smart contract had some sort of logic that was based on it starting with an ether value of 0. Well, somebody could look at your smart contract, especially in the case of like a smart contract factory, all the subsequent smart contracts must start with an ether value of 0. Well, somebody can just cruise by and basically start putting ether into those contracts before they're even created, which could really screw up your contracts, right? Because they'll know the future addresses of these smart contracts. So you can send ether to smart contracts that aren't even created. Anybody? Okay, that's it for the technical details. So let's think a little bit more conceptually. So let's go a little higher level. Let's think about smart contracts. So here's a quote from Nick Szabo. I'll just give you guys a sec to read through it. So Szabo basically came up with this in 1994, and last time I checked, that was a few years before Bitcoin. So a lot of people were working on concepts like this. So why smart contracts? Why come up with stuff like this? Well, if the rules of the game are out there, transparent, and people are transacting in a peer-to-peer way, on a ledger or a database that can't be co-opted by sort of any small group, and it's immutable, then we can do things like we can have things execute like a lot more fairly, transparently, and fluidly. So that's the hope, is to take things that are previously were like wet. This is what Szabo, he calls it like dry logic, wet logic. So like things that were like legal terms that can be, interpreted in different ways by the people who are sort of signing the agreements or the people who are interpreting the documents. And if we can just turn this into a protocol and have it be like just kind of very dry and executable, then we could probably get to some more efficiencies like in markets or between individuals. So in context of Ethereum, the smart contract overview would be this. You're basically writing code in Solidity or some other high-level language. You're welcome to try to write it in the EVM bytecode if you want, but it'd be a little bit difficult. It's stored on the blockchain as this contract account that I mentioned before, and the functions are called by sending transactions to the smart contract. And these transactions don't have to send ether. So yes, you have to send some small amount of ether to pay your gas costs, but you don't actually have to be transacting in ether. So you can hit a smart contract and transfer a value of 0, but still pay some amount of gas. So you're not actually sending ether to the smart contract in all cases. The gas costs must be paid to execute, even if no ETH is being sent to the contract, kind of the same thing that I just explained. And they have to be, the gas costs are paid by the user, even if some transaction fails. So, this is sort of like a runtime error. You expected the output to be Y, but it resulted in, some runtime error or some failure, and your output was Z, or it just basically came back and said, we had an error, we had to roll back to the previous application state, but you don't get your gas that you paid for that transaction back. So contracts can call, and this is also so you can't like spam the network. Like you can't just go blah and, kind of DDoS the Ethereum network with a bunch of bogus transactions. Contracts can call functions and create instances of other contracts. I mentioned that before. Smart contract factories would be kind of a colloquialism for that. Functions are computed and verified by all the miners. We covered that. And an ERC token. You guys may have heard of those. They're a single instance of a smart contract. So ERC tokens don't live like, they're not all like a bunch of different contracts. It's just one contract that maintains a ledger, which is in Ethereum, in Solidity, or in Ethereum smart contracts. It's basically just a mapping of an address to a balance. So it's the address that you saw before in the dissecting the function call example, mapping to a uint 256. So that's an unsigned integer 256 value, 256 bit in size. So that's an ERC20. It basically stores that and a few other like helper functions. All right. So let's wrap up this sort of prelim by basically talking about contract state and networks. So there's a few different Ethereum testnets that are out there that are public. This is so that developers can kind of, test their smart contracts with each other, around the world. You can also test locally, which is some of the testing I'm going to show you in just a moment. Every smart contract that's deployed is deployed on that network, and obviously it's deployed by a different address than if you were on a different network. It's gonna create like a different application state. So every smart contract kind of cross with a particular network is its own complete universe. So it's basically contract deployed on a particular network. That's like an instance of that contract, and it's going to have its own state and its own stuff going on. And likewise, when you redeploy a contract on the same network, you're getting a new contract address, new state, new everything. So that's just important to kind of check your head for sanity. All right, so let's talk about development. Did anyone like pre-read my slides? Did anyone install any of these tools? Hands up if you grabbed Truffle, if you grabbed Ganache CLI. Are you guys gonna follow along? Are you guys gonna be my experts? Hands up if you've done all of this before. Has anyone just gone through the whole thing? Like the whole meal deal? You're a smart contract expert, you're auditing smart contracts in your spare time for $250 US an hour? Anyone? Nobody wants to tell us. If you are one of these sort of smart contract expert pro people and you've kind of gone through all these dev tools and you wouldn't mind, we will have like at least a couple of short breaks where I want people who are actually kind of have their laptops open and they're willing to kind of try out a few things. We're going to take a couple little intermissions, and I would love your help to just mill around and see if people are having trouble. So we'll break, and then I'll be very clear about like when we're kind of coming back as a group. But let's talk about Truffle. What is Truffle besides being delicious? What are truffles? No, Truffle is simply the name of a sort of like an overarching development suite. It's put out by a team out of Consensus. Basically, when you install Truffle, you get this whole suite of tools. So what does it come with? It comes with a Solidity compiler. It comes with a test harness, which is basically just a testing suite. It uses Mocha underneath the hood for the JavaScript tests, and then it has its own sort of flavor of how it runs Solidity tests. It comes with a development blockchain under the hood that is in fact Ganache CLI, but they've sort of even wrapped it up and made it much more simpler. We're gonna kind of go through Truffle, and then we're gonna separate, and we're gonna run Ganache separately, just so that we can see the two like kind of separated. Ganache will let you, if you run it on its own, it'll let you kind of customize a bunch of stuff. You can customize block times. It's kind of cool. You can like simulate a really slow blockchain like the Ethereum mainnet. Just kidding. I'm trying to make this a little bit interesting, guys. And feel free, if you have questions, just put your hands up. It also comes with like a module loader. They say that you're loading these truffle boxes. They really try to keep the whole truffle metaphor going. But basically you can unbox these little sweet treats from the Truffle team. And basically they're just examples that you can use. So in this first instance, we would be downloading just with very few lines of kind of in our console, whether you're on a Mac and that's Bash, or whether you're just using a Linux terminal. You're basically just going to install Truffle, and you're going to make a directory for this MetaCoin box, which is just their canonical example, and you're going to unbox it, then you're going to run the tests. So this is, did anyone do that, by the way? You ran your tests? Nice. Okay. It only took you 6 seconds? Okay. 6 milliseconds, or? Oh, my test took 8 seconds. Yeah, I'm a little sluggish. So I don't know what I was doing, but basically, this is all running. This is all running locally on your machine. So when you hit Truffle test, which is the last line here, basically what Truffle is doing is it's spinning up Ganache CLI. It's creating like a whole little simulated blockchain. Then it's creating 10 unlocked accounts so that you can run your tests. And then it's basically starts, well, it compiles your contracts. So it takes your contract from Solidity code, and then it compiles it into EVM bytecode. It deploys it onto the sample blockchain, and then it runs these tests. It runs 2 tests in Solidity, which are the 2 tests up here. And then it runs 3 tests using JavaScript, using this Mocha test harness. So basically, that's a lot going on in like a single command line command. And so that's why today we're gonna like pull it apart a little bit, and we're just gonna kind of figure out what's going on so that we know what are these tools doing, like what's going on under the hood, right? All right, so like basically right away, we don't just keep wanting to write Truffle test, Truffle migrate, Truffle do this, Truffle do that. We actually want to go into the Truffle development CLI, like command line interface. We want to jump in, we want to execute commands from inside our sort of test network, right? So when you type in Truffle develop, you're basically going to have this console thing print out that says it started this development blockchain, and it started it at this particular, well, your local host at this particular port. So this is kind of similar if you guys have ever done like an SSH, like you've kind of tunneled into another computer, or you've used PostgreSQL's pSQL interface to issue SQL commands against a locally running or remotely running database. So this is exactly, like Truffle's basically giving you the tools to have exactly that interface, and that's what you're getting here. So you'll notice that your console changes, and it changes to Truffle bracket develop, and then you can execute the same command that you executed before, test, except it just kind of goes a little bit smoother, a little bit faster. Maybe you can get to this gentleman 6 seconds or less, if you really want to be a pro. And then you can also do things like from here, you can call migrate and migrate dash reset. That'll become, if you guys are like continually redeploying contracts, that'll be like your favorite command. So there are more options. So first you would, if you want to exit Truffle develop, and then you want to just type Truffle -- help, you'll get a list of commands like build and all this other stuff. So you guys, I'll leave it to you to kind of dive a little bit deeper into those. But I do want to talk about what's actually happening when you're in this Truffle develop, and just sort of, how you can kind of see what's actually going on under the hood. And that's through looking into Ganache CLI and basically diving a little bit deeper into that. So how we doing? Everybody okay? Like for those that do have the tools installed, you were able to run this successfully. Hands up if you weren't. Having a little trubs with the... It's not with Truffle? Okay, did you do the unbox here? Okay. This gentleman with the Keep Key shirt, you seem to be a bit of an expert. Maybe you could. I did issue a warning about getting the latest NPM and Node. Okay. All right, so this is just sort of, I think once we get to the end of part 1, which is coming up really soon, we'll take a short break, and I'm just gonna do a time check. We're good. All right, so Ganache CLI. So what is this? This is the test blockchain that's running under the hood. So this is what, when you hit Truffle test, a bunch of stuff was happening. These contracts were being deployed and these tests were being run. So transactions were being issued, but we didn't see any of that, did we? We didn't see any transactions. We didn't see anything. So we want to we do want to take a look at that. I will come back to this slide, but I just want to kind of show you guys what that looks like. You will have to edit your Truffle config here a little bit. You'll basically just have to say you want to use for development and testing the Ganache CLI. So if we look at the slide, Ganache is not going to boot up on this port 9545. It's going to boot up on 8545. So what we're doing here in a Truffle config file that should be in your root directory of your Truffle box. So this would be the MetaCoin box. We're just going to change that so that for development and test, Truffle knows that we want to run tests and we want to jump into Truffle develop against Ganache CLI. So that's what that is. And I'm just going to bring up my terminal here. And I'm just going to get into the MetaCoin directory. So I'm actually going to bring up 2 terminals. Oh, it's very small, isn't it? Is that better? All right. So I'm going to bring up 2 terminals. And in one terminal, it doesn't really matter where I start Ganache CLI. It's sort of going to be, think of it like a local database server. It's just going to be kind of floating around on my machine at localhost :8545. So if I type Ganache CLI, it's basically going to boot up here. That was nice and fast, huh? I'm looking at you, Mr. 6 seconds. You got to pick somebody. And then especially if you're doing this interactive stuff. Sorry, man. So when you hit Ganache CLI, I just scrolled up here to show you guys, you'll see it's going to dump out these available accounts, and it's basically giving you all these 10 accounts. They all have 100 Ether. You might as well just leave right now. You're rich. It's just on your machine. Anyways, and then there's the private keys for those accounts. In case you guys are doing some real cool, gangster stuff, you can use those private keys. I don't know what you're going to do, but it will also give you a mnemonic. So, it just spits out some of these random keywords. You can, in fact, connect your Firefox. It looks like Firefox. You can connect your MetaMask to this little wallet that just got spun up out of nowhere. You can connect your MetaMask by using this mnemonic if you want. It's kind of cool, but we won't be doing that today. Just want you guys to know it's there. And you'll notice at the bottom, it's listening on that port, 8545. So this is the port that we made our change to in our Truffle config, right? So now we have truffle config, truffle-config.js. It's configured to use this network 8545 for development and test. And we have Ganache running on this network, right? So now what we can do is we can jump back into our MetaCoin directory. And I mean, unless you're fancy and you're using Screen or whatever, I just have 2 terminals going. So I'm just going back to the terminal that's in the MetaCoin directory. And basically, I'm just going to type truffle test. And I'm going to flick back to Ganache CLI. And all things being good, we should see this action happening. So you guys see a lot of this stuff going brrr. Bunch of lines coming down. So those were essentially our contracts got compiled. Nothing really happened in Ganache CLI, right? That was the Solidity compiler. That's another thing that Truffle kind of abstracts for you, is it's compiling your contracts into bytecode. That's happening using the Solidity compiler. We didn't see any of that action. Once the contracts were compiled, they were deployed onto this local blockchain, this local Ethereum blockchain that we're running under Ganache. And basically all the stuff that we saw dump out was essentially a lot of contract creations. It takes little snapshots. It does all sorts of interesting things. And this is just for you to develop and debug. So all the way back up to our accounts, we have our 10 accounts. And then basically we start going down and you can see contract created, contract, there's the address, right? You can see transactions. And another thing about Truffle and about the when we run Truffle test is that it will also it will redeploy and it will do a bunch of stuff. You can set up your test to do anything you want really against this test blockchain. So you'll notice quite a bit of transactions were issued just for those 5 tests, which is kind of cool. So you can see everything that's happening here. If we had booted up Ganache CLI with a configuration for a block difficulty or something like that, it would in fact go through the hassle of simulating mining the block and stuff. But right now, it's at block number 6, and the block difficulty is super, super simple. So it was very, very fast. You guys saw that kind of roll in really quick. And back in Truffle test, it basically spat out our tests. Notice it said it's using the network development. So that's the network we specified up here, which is great. You can tell it to use other networks. This is up to you guys. You can specify hey, I want to have a network config for Rinkeby. I want to have a network config for Kovan. I want to have a network config for mainnet. This is where you would do all of that, and you would set that up. Okay, so who made it past the running Ganache CLI separately and then testing against it? Is everybody good? Who's having trubs at this point? Are we stuck? Okay, let me just see how much is left here. Okay, I've covered this and the output. I can talk about that in a sec. Okay, we're at part 2. So guys, I do want to take a little bit of an intermission here because I know it's a really long session. So the second half of the session is all about writing tests. We're only going to break for less than 10 minutes, and then we're going to come back. We're going to talk about writing tests, deploying contracts, elsewhere. And I am going to show you an example of basically using your own front end and web server and Web3.js to talk to your locally deployed contract. So that'll be kind of cool. But I'm not going to teach everybody JavaScript. But we're going to look at a few bits of JavaScript to make that happen. So we will just kind of break out. Hands up really high if you want me to come by. If you want this expert, what's your name? This pro in the Keep Key shirt and in the hat. He's very humble. What's your name? Sean. So if you want me to come by, Sean to come by, anybody else that's sort of well-versed or has sort of got this running and you feel like you want to maybe help out. Hands up high if you want to have, if you want one of us to come by. Yes. Okay, couple people. All right, we'll cruise by, and then 5 minutes, guys, we're gonna jump into talking all about tests, how to write tests, and all that good stuff. I hope, I know some people may have had kind of more complicated configuration issues, like going a little bit deeper into Node or NPM. I'm sorry about that, but I don't make the tools. By the way, I should have said, I am not employed by Truffle, Consensus, whatever. They're good tools though. They just, they're a little finicky. They require, a particular sort of, particular version, etc. Now I hope that we could just kind of move on. There's a little bit of kind of stuff I want to get to. We're going to hit 3:30 and then we're done here, but I also want to open up some time for Q&A. This section is a lot shorter. I have most of it kind of in the slides as well, so we can talk through it. But if we have some time, we can go back, we can do a little coding, we can have some fun. So let's talk about writing tests. So basically what you guys are doing is you're deploying these smart contracts that are, first of all, people are paying to hit these functions in your smart contract, right? They're paying gas in the form of Ether. If you have, a game or you're selling something like an NFT, people are potentially paying in Ether for these things, right? And if you're on the mainnet, then Ether has a real monetary value. So we probably want to write some tests. So we probably want to make sure our smart contracts do what they say they're doing. We want to make sure that the balances all add up at the end of the day, that everything's accurate. And we probably want to, and this is just, this isn't me, I don't even know the names of any of these companies, but this is just probably a personal recommendation. You probably want to get someone else to look at your smart contract. So you want to get what's called an audit. And one way that you can significantly, reduce your costs of getting an audit would be to write really comprehensive tests and document your contracts really, really well. So let's talk about writing tests a little bit. So we unboxed this MetaCoin Truffle box, and it came with a solidity test. Actually, let's just jump into that really quick. In the test folder, it came with a test MetaCoin smart contract here, and that was executed. So we saw those first two tests, and then there was a break, and then there was 3 other tests. The first 2 tests that we ran up here, these were happening from this test metacoin.sol. And so these tests, this is basically Truffle's own kind of internal test runner for testing in Solidity. So you can test against the Solidity code. You can also write your tests in JavaScript, and you can test against your contract using JavaScript. I'm going to talk primarily about the JavaScript side of testing, but that's not to say that you should completely ignore the Solidity side of testing, because there's some very intricate and kind of crazy things that you can do in the Solidity tests. But that goes really, really deep into smart contract security. There are some people floating around here at the blockchain training conference who are basically these smart auditor people I alluded to. And I believe they're doing talks, but their talks are after mine. Makes sense, right? And they're going deeper into smart contract security. They'll no doubt tell you about what to look out for in a high level language like Solidity, and how your code can be susceptible in sort of its, you could catch it in testing, but also how your code might be susceptible to hacking or attacks as it gets compiled into Ethereum bytecode. Things change, and they don't always do what you expect. So it's just really cool stuff. But again, it's a little bit deeper, a little bit beyond the scope of this introduction. So let's talk about just getting our contracts to kind of do what we expect them to do, and we'll talk about these tests in the context of JavaScript. So has anyone used Mocha before? It's a test framework for JavaScript. Mocha. Has anyone had a Mocha? Has anyone had a Truffle? Has anyone had Ganache? Does anyone know what Ganache is? What is it? I don't even think I know. Is it like an icing? It's a hard chocolate shell. Yeah, that's right. I think that sounds good. You can tell, guys, I'm a real connoisseur, very cultured. There's also actually the Truffle team has another thing. It's all like dessert themed. They have another whole thing called Drizzle. Now, Drizzle is really interesting. Drizzle is essentially for like front-end frameworks like React or Vue JS, and it's basically how do you inject your smart contract state into your front-end app, right? So you're drizzling in your information. It's really weird. Anyway, they're an interesting team. This is being recorded, right? Awesome. Okay. So you have your contract called MetaCoin. Okay, so this is what the first little itty bit of the JavaScript tests look like. I have some comments in here. We'll maybe unpack those comments later. But what I'm really showing you is just this first test here. So I'm showing you here in the slide, and all it's going to do is it's basically going to grab an instance of the deployed contract. Remember, one contract, one network, like one smart contract .sol kind of code file deployed onto one network. That's an instance, right? It's going to grab that MetaCoin instance, and then it's basically going to get the balance of the account. Now, I mentioned there was 10 accounts. Those accounts are in an array. So it's going to get the balance of the account at the 0 index of this array. That account is also the account that deployed the MetaCoin contract. And just really quickly, if we look at the constructor, the balances of the transaction origin is going to be 10,000. So that's basically a fancy way of saying who deployed this smart contract, right? So what we're going to check is if the MetaCoin balance of that account 0, the account that deployed this smart contract instance to this network, has a MetaCoin balance of 10,000. So that's what this test is sort of asking us. And you can see, like, if you come from sort of front-end coding, JavaScript, it's fairly simple. The only interesting bit here to think about or to consider is assert.equal. Like, what is assert? Has anyone used Chai? I always say Kai. I don't know why. Chai. So Chai is basically this assertion library. So you wouldn't know this because there's no import or require statements up at the top of a Truffle test, like this test.js. Where's the test here? There's no, I'm up at the top. There's no imports or anything, and this can be kind of confusing. You're like, okay, it looks like JavaScript, but there's these extra things. So assert is basically coming from this Chai library. It's, get it? Mocha, Chai? Everyone getting it? Okay. So basically, Chai helps you test for equality. It helps you return what you need to return from these test functions. You also notice this it here, this it should do this thing. And then we're booting up an asynchronous function. Apologies if you guys aren't like up on all the modern JavaScript, but basically it's an asynchronous function, but it's gonna stop here, and then it's going to spit out this last value. So anyway, that's basically what every test looks like. So let's talk a bit about these contract instances. And again, I'm trying to pull apart like what's going on under the hood. So when Truffle compiles your smart contract, it actually produces this artifact file that stores I call it the ABI or the ABI. So it is the application binary interface. I don't know why, guys. But basically, this ABI is the interface to the bytecode. So remember I said that a smart contract gets compiled into bytecode, EVM bytecode, Ethereum Virtual Machine bytecode, and it's put on the Ethereum blockchain. And then you're going to call a function somewhere by using that function signature thing. So it's the hash of the signature of the function. And so based on the contract address and the EVM bytecode and that function signature, it's going to point directly at that function. And basically the ABI is a way for external clients and stuff to know where that function is or how to generate that hash to get into that function. So the ABI is the interface for our smart contract as it's compiled already, okay? So Truffle creates this artifact file, and then when Truffle deploys these artifacts, they create these JavaScript objects. So basically, you can access like a live JavaScript object where you can talk to your smart contract by calling MetaCoin.deployed. So these are convenience functions that Truffle gives to you. And this, if you want to go a little bit deeper on this part, this is done through truffle-contract.js, which is kind of like a wrapper around Web3.js, which I will show you in a moment. So we need to connect to the actual deployed contract instance. So that's what we're doing here. And then through this JavaScript object, we're gonna be doing things like signing and sending our transactions just by way of function call, like making function calls. So let's think about the test harness a little bit. So we start by saying we want to test this particular contract, and then it returns, it has a callback function that's basically filled with those 10 accounts that we want to test. So those 10 accounts are unlocked. So we don't need to actually get into the nitty gritty of having like a MetaMask pop up on the screen and have the user commit to every single function we want to test. Those accounts, we can just sign those transactions and move them through. And then you start with a test with a descriptive title, like it should put 10,000 MetaCoin into the first account or the account that deployed the MetaCoin contract. And every test function should just be returning a promise. So basically, it's a promise in JavaScript. You can you can create a custom promise. You could say new promise, whatever. But again, I'm going to hold myself back from going deeper into JavaScript and just talk about this stuff. So let's look at this MetaCoin test. So what would happen? Let's say if you were running this test and you had an exception. You could test this by basically wrapping it in like a try-catch block. So just kind of mess around with it a little bit, get to know like how a little bit, like it is just JavaScript at the end of the day, so you can do a lot of interesting things. You can create any variables. Like I typically, if I'm writing a test, like I like to, even up here, outside of each individual test, like you guys can basically start naming people. So you can say, Alice is going to be accounts at 0 and Bob is going to be accounts at 1, right? So you can do that, and then down in here, you can use Alice. So you can do anything you want inside your test, just as long as like logically you know that they're gonna work, right? Like, if they break, then you either have to update your smart contract code or you're testing the wrong thing. So just always make sure that whatever you do in your test, you should kind of try to keep it simple, try to keep it clean, test only one thing at a time inside here, like inside a particular test. So you see like every test starts with just a very descriptive title of the one thing that it's going to try. This test is a little bit more complicated, but basically it's because it's sending a coin from one account to another. And you see they've sort of they've given like some sort of some aliases to these accounts as well, just to keep it simple. Okay, so there's this concept of a big number. Has anyone heard of this before? You guys have heard of big numbers? bn.js. So also I should kind of maybe, like, we're getting deeper into this section. I should preface this by saying this stuff like Web3.js, there's like a bajillion different versions, and it's probably going to drive you crazy. Same thing with Truffle, and not all of them like play nicely. So, you know, like Truffle version 3 wasn't working with, you know, Web3.js 1.0 beta or whatever. And then these things get out of sync because they're being developed by different teams. And likewise, I'm pretty sure they switched the version of big number that they were using. So it gets a little crazy. But you should know that underneath the hood, there is some concept of what is called a big number library. There's some sort of big number JavaScript library running underneath the hood here. And the reason is because remember Ethereum all the way back to the boring beginning, when I said Ethereum is a 256-bit virtual machine, it's so that it can handle really, really, really large numbers. And basically, this is just like a rough sketch example of you want to test equality for all these big numbers. Now, that being said, a lot of modern browsers have like kind of native big number support, and they're kind of moving, they're kind of phasing this in. My general rule of thumb, though, guys, if you were writing tests, you're gonna probably want to compare string equality between things, or use the native EQ call. And the reason why is because if you don't know the environment in which the test is running and you don't have big number support, you might like lose, you know, if you're just trying to spit this stuff out to numbers and test if those numbers are equal, you're gonna lose like accuracy at some point, especially like if you get into like really, really, really large numbers. So I would recommend like, you know, like just brush up on, you know, what is Mocha? How does it run tests? Just kind of get your head around that. You don't need to know much more than basically this kind of stuff. Like, you know, you're inside a test runner. It's gonna have, there's a setup, there's a teardown, and a few other things you can look into if you want. But you shouldn't need to know much more than this to do quite a bit of testing. But then also that there's things like chai running, where you do these assertions, assert equal, right? And there's also things like big number. You really should just know that this is all happening behind the scene. Okay, so I'm really glad I didn't go too far deep into this. I did want to get like all the way out onto a test network, but then I was like, you only have an hour and a half. So, so we're not going to go like out onto like a Kovan or Rinkeby or whatever, Ropsten, like all these test networks. We're not going to go out onto a test network today, but we are going to look, just after this section, we're going to look at like talking to locally deployed contracts from our, from just like a web server. So just a quick recap though, you know, what network am I on? You want to just really give yourself like a sanity check. Like if you're getting a bunch of errors and you don't know what's going on, or even sometimes really cryptic errors, like it says like, hey, you tried to call this function, but was there not enough, was there not enough gas? Question mark. I mean, sometimes you get that error in the console and it just simply means like you're not even connected to like the right contract or the latest deployed contract, but that error doesn't help you with that at all. So basically, you want to just always check, you know, are my contracts deployed? Are they the latest ones? Is my, you know, when I'm writing my application front end, is my Web3.js or is my contract instance pointing at that exact contract, the one that I just deployed that I want to find out information about on my front end? So Make sure you know which contract you're on. If you are trying to connect MetaMask to Truffle, I kind of alluded to this before, you can do that through this mnemonic that gets spit out by Ganache CLI and Truffle Develop. And then this is a little dated actually, and I know the rules have changed just recently. Just with how you hook in with the Web3 providers. We won't cover this today, but just know that when users are cruising by your, I'm presuming it's going to be a web app, but I know some people might do native development. But when users are cruising by your web app, it is going to be with a dApp browser, and that could be any number of wallets or what they call kind of affectionately a Web3 provider. So some sort of Web3 instance will be injected into the page, and then it's kind of up to you as a developer to kind of be looking and listening for that Web3 provider, and then basically you're going to have to trigger it and say, I want the user to be aware that I want to access the Web3 provider. These little confirmation dialogues, like in MetaMask, will pop up. It'll say, this web page wants to take a look at, your account, whatever. And you say, sure. And then that's when your code using like Web3.js can start to ask the user, hey, do you want to call this function? Do you want to send this amount of ether to this address, right? And it'll pop up in those confirmation dialogues. I think maybe most people in here have seen like, a dialogue pop up and it says, set your gas price, set your gas limit. Do you want to actually accept this transaction? Right? We're all okay? Okay, so really quick, just before we run out of time here, I've got about 10 more minutes. I want to talk to you guys about connecting to contracts. I'm gonna boot over this section really quick, but basically when you guys run Truffle Develop, you can actually just start typing JavaScript like inside that Truffle Develop command line interface. So I mentioned before, it is kind of like a PostgreSQL command line where you could just start issuing commands, and you can issue commands in JavaScript. So you can basically say, I want to get the latest deployed MetaCoin instance, and it'll give it to you, provided that you've already deployed the MetaCoin contract. So you have to write, you'd have to write Truffle Develop, then you go in the developer console, you type migrate, it's going to deploy your contracts, and then you start typing like, okay, give me an instance of the MetaCoin contract, the latest deployed one, right? And then you can go grab the accounts, store that in a variable, and you can start, plugging away with JavaScript and having a good time. But that's not that cool. We got to get a little bit wilder. So now we want to basically, oh boy, this looks like a real mess. Does anyone love my colorful code? I like it to be really colorful. This is directly copied and pasted from my console, my IDE. I think what I'll do is, so this is on GitHub. I think I posted a link to it in Schedule Wedge, whatever it's called. I posted a link to this under this session. So if you guys go to Schedge, it just says in the description of this section, it says materials, but you can also just find it under my name on GitHub. It's just the repo BTC19. My GitHub, it's just like a picture of my face. You'll find me. So let's just jump into the code itself, because that'll be a little bit more interesting. So I'm just gonna close a few of these files. One thing I'm gonna do before I even attempt this is I wanna make sure I'm doing the right thing, I'm on the right network. What I'm going to do is deploy the MetaCoin contract to Ganache CLI, and then I'm going to load up a local web server, and then I'm kind of gonna need to use I'm using Web3.js, so I don't have the convenience of Truffle contract or this .deployed method that magically finds the last deployed contract. So I will need to do a little bit of kind of sleuthing to figure out that last deployed contract. But I'm going to find the last deployed contract address, and then I'm going to connect to that. So let me just show you guys what that looks like a little bit. It's in this app folder here. I put my own copy of Web3 because I just, like I said to you before, there's all these different versions of Web3 and all this stuff floating around, and I just didn't want, I didn't want there to be like inconsistencies and stuff. So I am loading something from a CDN, but it's just a JavaScript polyfill so that Web3 will run properly. So you see this is a really simple web page here. It's just accounts and this MetaCoin balance. So we're looking for the MetaCoin balance, but in terms of Ether. Just a quick recap here. Sorry. The first account gets a MetaCoin balance of 10,000, but it's also it's using a library. Again, this isn't the section about smart contracts, so there's later sections about smart contract programming, like Solidity programming and stuff. But basically, it connects to a conversion library, and it's important to note that basically the conversion rate is 2 to 1. So basically, the MetaCoin balance in Ether of account 0 will actually be 20,000. So that's all I wanted to show you before we kind of go and deploy this. So now, the moment of truth. You guys can tell I'm really excited to do this in front of you, right? Okay, so again, I'm also gonna just get out of Ganache CLI. I wanna wipe this thing out. Another thing that's actually kind of like a little bit overkill, but it's probably prudent to do so, is I'm gonna delete the build folder. I just wanna make sure there's no errors. I did this upstairs in my hotel room, so I made sure it works. I'm deleting the build folder of the contract, so that was all the compiled contracts, those real nice Truffle artifacts that were compiled for me. I wanna make sure that I'm getting the cleanest version. So back here in this terminal, I will type Truffle deploy, or sorry, no, I will write Truffle migrate, and I will be, I will be migrating my contracts to this Ganache CLI, this fresh instance of Ganache CLI that I booted up at port 8545. And then in one more terminal, I am going to, I'm gonna CD into MetaCoin here, and then I'm gonna run serve, which is just a JavaScript, like kind of NPM, sorry, it's a Node.js server, and it's running at localhost 5000. So we have 3 terminals, 3 different things happening. We have a local web server, which is serving out everything in the MetaCoin directory. So that includes app, that includes contracts. These, it will include app, and it will include the build folder, which will include our lovely Truffle artifacts. And basically, it just needs app and build. I can show you guys what all it's connecting to later. But let's deploy that. Whoops. Truffle migrate, and this should compile the contracts fresh. And we'll see the contracts compiled, and we should see a build folder appear, and the contracts are being deployed, so they're being put onto our Ganache CLI, so we can verify that that's actually happened. And again, you should do this. You should don't just kind of blindly assume that everything's already hooked up for you. Just make sure you're kind of doing the right thing. I've got like a bajillion little local things running. So under localhost 5000, which was that serve where serve was booting up the app, and then also under the app directory, right, which is where the index.html, app.js, web3 is running. We should go here. Of course, it's not working. Oh no. Am I even online? Yeah, I am. I've got something, and I've got the network here. Oh yeah, it's just the fave icon. Okay, so again, I mentioned that we had to do a little bit of sleuthing to find out what is the address of our recently deployed MetaCoin contract, right? And so I printed out this object on purpose. This is basically the Truffle build artifact. So let's take a look here in app.js. So I've gone and I've fetched, hold on, I'll just turn on line wrapping. I've gone and I've fetched the artifact, right? So I went to build contracts metacoin.json, and the most recent build of the Truffle artifact was getting printed out in the console here, okay? Now, why is that important? Well, I need to know the network that this contract was deployed on, or more specifically, I need to know that address. So basically, I'm just gonna copy this because I'm kind of set up here to basically like kind of choose my network and then go get the address field from that. That's just how this is set up. I could just paste in the address as deployed address, right? But what does that look like, guys? Anyone? Shout it out. Huh? That's the current time, right? So that was the time I deployed this contract, and that is, you know, in fact, some timestamp of right now. So that's the network, that's the MetaCoin contract instance that we're looking for. So then if we refresh this, we should get the accounts. So I'm printing out the accounts and I'm putting that onto the HTML page. So I'm just kind of updating it. And then I'm getting this MetaCoin balance in Ether of, well, I affectionately named account 0 Alice. And then I basically said, let the Ether balance be instance.methods.getBalance in ETH for the address Alice.call from who is calling this method? Alice. And how much gas is she going to use? A lot, because I don't want it to fail. And then I just printed it to the console, but then I put it into this balance field. So yeah, very simple, very succinct little example. But I really hope that this session helped you guys kind of wrap your heads around a lot of the moving parts that goes into basically just getting from, okay, there's this thing called Truffle, and then I actually want to write a web app that talks to a smart contract. How do I do that? So I hope that we kind of got there, and I hope that you maybe learned a few more things about smart contracts and stuff along the way. We got like 5 minutes for questions. Does it? Maybe 5 minutes? Maybe not. Nobody's kicking us out. We have some time? Okay. Cool. Anybody have any questions? I mean, that's kind of, oh, that was really small for you guys, but sorry. Anybody have any questions about that? Yeah. Sometimes it just fails anyways. I don't know why. I'm pretty sure I can actually get rid of this because it's a dot. There's a distinction here between like a dot call and and calling a function and actually like modifying application state. So dot call is sort of like kind of like doing a dry run, or you use dot call when you just want to read application state directly from the blockchain. But if I save that and try it out, you don't, right? But earlier, I think I was doing something else, and then it was like failing, and that's just like a leftover. So sorry. Anybody have any other questions? Yeah, actually, let's go to Truffle's website. We did it all without doing that. So, okay, so sweet tools for smart contracts, right? So we looked at Truffle today, which is this guy over here. So Truffle's kind of like the Uber wrapper over Ganache. It doesn't have a lot to do with this one on the right called Drizzle. I mentioned that just briefly. It's for integrating with front-end frameworks like React or Vue.js, for example. However, Truffle does wrap around two key tools, which is basically the Solidity compiler called Sulk. It's like Solidity C compiler. So Truffle wraps that up, and we did not unpack that part. That part's its own whole thing. If you want to go into like how smart contracts are compiled from Solidity to EVM bytecode, that would be diving deeper into the Sulk compiler. Truffle also wraps up Ganache CLI, which is pictured here in the middle, I believe. I don't know. Is that Ganache? But basically, Ganache CLI is this test blockchain. It was previously called just Ethereum-test RPC, or just test RPC for short. This lovely person would like to help you about Truffle, Ganache, Drizzle, or Truffle teams. Let her know. Okay, so these are the tools, right? You've got Truffle. By the way, Ganache doesn't have to be run from the command line. It's a full desktop client. So it boots up. You can see the accounts. You can see the ether in the accounts. They have a whole GUI to the whole thing. I just think it's a little overkill. But anyways, so those are the two tools that we kind of primarily looked at. And then the last step that we looked at today was really how did I get some JavaScript, this amount of JavaScript, just this little itty bit of JavaScript, to spit out the balance of some wallet? Well, I mean, I was leveraging the Web3 library, which is sort of Web3.js is the Web3 JavaScript library that's put out and kind of sponsored by the Ethereum Foundation. However, that's not where kind of the story ends. There are other frameworks here. So Embark would be a different framework from Truffle. That's sort of kind of an Uber framework wrapper around a bunch of tools to build your dApps. Different Web3 libraries to talk to Ethereum smart contracts. So for example, you have this contract, it's deployed on this blockchain network. Let's say it's Rinkeby or something like that, or it's just locally running on your Ganache instance. You have to take some JavaScript library to connect to that smart contract, right? And then you have to have some JavaScript object that is an instance of that contract, so that you can start firing off, you can start building transactions, and you can start you can have users, if users are connecting with their wallets, they can sign those transactions, and you can what am I trying to search for the word here? You can issue them to to a node through Infura or something like that, right? So these JavaScript libraries like Ethers.js, ETH.js, Web3.j, these are alternatives to Web3.js. I know all the names kind of, they seem like they're just mashed together, but these are your your Web3 libraries to connect to your smart contract instance. These libraries basically wrap up the functionality of calling functions on that smart contract, talking to the accounts that are basically connected to your app at any moment in time. So they kind of wrap up all that functionality. There's some editors there that will help you. There's this Remix editor. It's the online editor. It's changed a lot, in the last year. It's gotten really, really funky with a bunch of plugins and crazy stuff, but it's always an option. It's a way to just write Solidity code, or I'm not sure, but I think it supports this new Python variant called Viper. But you can write it right in the browser. You can deploy it to a test blockchain and do all this cool stuff. And then there's there's smart contract libraries for smart contracts. So I mentioned ERC20 tokens because people have heard of them. There's also NFTs and a whole bunch of other stuff around ownership and escrow and all sorts of cool stuff the most popular of those libraries is called Open Zeppelin. So you can go check out their contracts, and you can import their contracts and base a lot of your contracts off of those contracts. Oh, I had a challenge. The challenge was basically to finish, if we had time, it was to finish this, albeit very, very simple front-end example so that, you know, two accounts can send MetaCoins to each other. Try that at home. But yeah, that would be, if you want to kind of try to solidify your knowledge from this session, that would be a great way to do so, because the smart contract's all set up for that, to send MetaCoins from one account to another. In fact, the JavaScript's already there for you in the test, right? So if you look at the MetaCoin test, whoops, it's right here. So you see that they're getting the starting balance of the two accounts. They're specifying the amount of MetaCoins that they want to send, and then they're basically sending a coin to account 2. So account 2 is the receiving account, the amount that you want to send, and it's from account 1. And so this would be kind of analogous to what you would use inside app.js. Instead of just checking the balance here, you would use the send coin function, right? So one way to maybe flesh out this example is to provide a balance field for both account, like the account at the 0 index and the account at the index of 1, which I would call Alice and Bob, right? Because we love Alice and Bob. And basically I would issue a send, or have a button that issues a send. It sends 10 from Alice to Bob. And then I would just I just put the button on the page and let people click it. And then after you've sent 10 MetaCoins from Alice to Bob, you're probably going to want to go ahead and, back in app.js, you're going to want to update the balances. So you're going to want to have some code here that's going to update the balances for Alice and for Bob, right? So one way to sort of like wrap up this session would be to flesh this out, and then if you want to get really fancy, have an input field, right? And specify how much you want to send from Alice to Bob. I think you asked a question, and then I just started talking. All right. Yeah, so just summarizing the tools, I would just recommend you kind of cruise through here, check out, like a lot of what I was talking about today was sort of, borrowed from the quick start and stuff in here. We're just going through their MetaCoin example because it's one that everyone can just kind of download. And it's also one that, like, I didn't want to give you guys a custom contract and then, like, I disappear and I'm not here anymore. And then you're like, how do I get help for this example? So I hope you guys check out the other sessions. We've got some really talented people here. And they're speaking a little bit deeper, like I said, on smart contract programming, smart contract security. So definitely check those out. Any other questions? I think we should wrap up. We're a little bit over time. Yeah. All right, guys. Thanks a lot.